Hello everyone, welcome to the MathCAD tutorial sessions. Today we're going to start with session number one, lesson number one, in which we're going to introduce the software as well as talk about some of the fundamentals of MathCAD and the use of functions, both the defined functions, the user-defined functions, as well as the built-in functions of MathCAD. So let's start with the presentation. And MathCAD is a problem-solving environment that can be used to solve a variety of math-based problems in a very visual way and a very user-friendly way. MathCAD allows the user to enter mathematical problems in a what you see is what you get form. Basically, you get a blank screen, and in that blank screen you throw in equations, and the equations can follow a specific sequence, so the equations can be independent from each other, or it just can be used to analyze things, or it can be used to just simply evaluate values and evaluate functions and evaluate equations, and is as user-friendly as that. So you're given all the liberty you want. There's no specific grid, there's no specific format in which you need to throw your equations at. Obviously you have to follow some precedence rules and so on, which we're going to talk about today, but it essentially allows you to solve equations on a virtual piece of scratch paper. So it's a very user-friendly software. It's one of the most widely used, if not the most widely used, mathematical software packages in both in college and outside and the workplace, because it gives a lot of flexibility and the ability to solve very simple and very powerful and very sophisticated problems. You can solve problems as simple as just evaluating a simple function, and you can solve problems as complicated as performing actual iterations and programming sequences and flowcharts, which we're going to cover in future MathCAD sessions. So you have to follow a problem-solving methodology if you're actually solving an engineering problem. An engineering problem basically means that you're going to be using this virtual scratch paper to solve a problem in which you input data, and you process that data, and then you visualize that data, whether it is by tables or by plots and graphs. You have to follow a specific methodology. First, state the problem, which is the problem that you want to solve, and think out the equations directly in MathCAD. You don't have to use a piece of paper to write down your equations if you're solving a dynamics problem or a statics problem. You don't have to write down the second law of motion, Newton's second law of momentum. Simply write those equations directly in MathCAD, either in text form or in equation form, which we're going to talk about the difference in a second, and then work out the problem directly using MathCAD. Enter the input data, and then graph the data if necessary, or just tabulate the data if that is the way that you want to render your data. So it is a very, as I said, user-friendly environment, very easy to learn, and it can do, although it's this easy, it can actually do very, very difficult things. So let's open MathCAD on your PC. One main window. We're going to open just one instance of MathCAD. Close the tutorial windows if you see them appear. We're going to try to move the red plus cursor. There's a plus sign cursor around with the mouse, and the main window, the blank main window, is your scratch pad, and the math toolbar allows you to view additional toolbars for functions, graphs, and other toolbars and for features that we're going to be looking at in the near future. So let's exit the presentation, and I am going to go to Start All Programs, and I'm going to go straight into MathCAD. And I'm using version 14 of MathCAD. You can open it up directly from here, or if you have created a desktop shortcut, or if your installation of MathCAD created a desktop shortcut, if you're using any of the computer labs here, you should be able to find a desktop shortcut. Just double click on it. So I have the academic version, version 14, and let's wait for it to open. And there it is. So this is all MathCAD. It looks like a notepad. It looks like a very simple text input software, but in reality there's a math driver behind all of these, and everything you type in, if MathCAD can understand it, will process it, and if it doesn't understand it, just simply puts a red underscore under it saying, oh, there's no way I can understand this, and I'm just simply going to leave it here for text and just continue entering whatever you want. You can also format this piece of paper. Notice that it has a right margin, and if you keep going down, if you scroll down, you will find that there is a page division. So you can actually format this your pad as for presentations or for a report. You can actually type things in a nicely formatted way, so you can turn it in as work. So as we mentioned, we can move this this plus sign right here is the actual MathCAD cursor. This is where you can move it with the cursors on your keyboard. This is where you're actually going to be this is indicating where the next data is going to be inputted, or where the next equation or where the next text is going to be written. And you can move it with the mouse by just clicking wherever you want it to be. Notice we talked about the MathCAD toolbar. This is a general toolbar which opens additional toolbars. For example, some of the toolbars that we're going to be looking at in this set of tutorial lessons is the graph toolbar, for example. This will allow you to input graphs in different formats, or the matrix toolbar, or the function toolbar, evaluation, or maybe the programming or Boolean, this one, the programming toolbar, and the Greek toolbar to enter Greek characters. Okay, so let's continue with the presentation, and you can go back to MathCAD and play around and try to look at the menus. Notice that it has very standard menus. MathCAD is only written for the Windows environment, so it's got the standard Windows menus, the pull-down menu with a file, edit, view, insert, format, tools, symbolics, windows, and obviously help. You can obtain help for your MathCAD different functions that you're using or different features that you're using. You can obtain direct help by clicking F1 over the particular function that you're looking for help on. So let's go back to the presentation, and let's talk about the equal signs. And we're going to be talking about these equal signs for a long time, but let's just introduce them. There's 4 kinds of equal signs in MathCAD, and it's very important that we understand the basic difference between them. For the time being, we're going to be using symbols 1 and 2. Okay, notice that there's an assignment equal, which is displayed in MathCAD as the column equal. Is used when you want to assign a value to a variable. When you're defining something, when you're defining or assigning a value to a variable, then you use the assignment equal, and it's entered into MathCAD using the column sign. Okay, column. Then the display equal is used to render, or when you want to display the value of a variable that already exists, then you use the regular equal sign. And for this equal sign to work, the variable needs to already be defined. If it's not defined, then when you type in equal, MathCAD will understand directly that you're trying to define something, and it would input the definition equal or the assignment equal. There's another 2 equal signs that we're going to be using later. One is the symbolic equal, that is used to set a variable to another set of variables, or for control purposes, or for programming purposes, and also for comparison purposes. You use the symbolic equal, and we're going to be getting to that in future lessons. And it's entered either with a control equal or the control plus. The global equal is displayed as 3 horizontal bars, parallel horizontal bars, and is used for definitions that take precedence over assignment equals. And you can use the tilde sign to display the global definition equal. The global definition equal can be used in any part of the scratch sheet of the MathCAD pad, and it will define a variable with no precedence, meaning that even if you define the variable at the bottom of your pad, at the bottom of your window, it will take precedence over everything that you define upstairs, and it will just replace it. And we'll be talking about this global equal as well. So let's try to enter some equations and display some values on MathCAD. So we're going to move this plus sign, which is the MathCAD cursor, to the upper left of the scratch pad, upper left corner of your scratch pad, and try to enter the following equation. We're going to enter x is defined as, notice, column, which will be displayed in MathCAD as column equal, 50 times 120. And then we're going to try to display the value of x, which should already exist. X is equal to, and we should get 6,000, right? 50 times 120. And then we're going to enter another equation saying y is equal to, this is definition equal, we're going to define y as x times 0.1, and then we're going to try to display the value of y. This is the way it should appear on your screen. Okay, you define with the column, but it displays as column equal, 50 times 120. Then when you try to display the value of x, you don't actually get 6,000, you get 6 times 10 to the 3, which is 6,000, but you get it displayed in scientific format. There's a threshold that we can define, we'll talk about that later, a threshold that we can change as to what's the maximum number that we can display in floating fashion, or what is the maximum value for displaying in exponential form or in this scientific notation. We'll talk about that. Then when we define the other equation, y is equal to x times 0.1, and we try to display y, obviously y will be 600, and since this value is below the threshold that is set by default, the threshold that is set by default for scientific notation is 10 to the 3, meaning that if a number is greater than 1,000, MathCAD will automatically display it in scientific notation, just to save some space, and if a number is less than 1,000, it will display it in floating point notation, like this, regular notation. Alright, so let's go up, and let's go to the next screen before we go to MathCAD. We can move equations and edit equation. We can select an equation to move it around by first clicking on the equation and then move the mouse around that selection until the cursor turns into a hand. Once the cursor turns into a hand symbol, we can click and drag it. We can drag it anywhere we want to. And let's talk about that directly on MathCAD because you'll see what I'm talking about. Alright, so I'm going to move the mouse, the cursor, somewhere here on the upper left corner, and I'm going to enter X column. By typing in column, notice that column equal is displayed. That means that MathCAD is getting ready to define something. 50 times 120. Enter. As soon as I hit enter, that value has already been stored and it's actually been executed and stored. The equation has been executed and the value has been stored. So when I say display me the value of x, x equal 6 times 10 to the 3. Alright? Then I'm going to move this down. As I said, I can just select one equation and notice that once the cursor turns into a hand, I can click and drag. See? Or I can move it sideways. Let's move this sideways and notice that nothing will happen. Now, the next one is y is equal to x times 0.1. X times 0.1, and now let's display y, and notice that we got 600. So notice the difference between the definition or assignment equal and the display equal. Now we already looked at how to move equations. We already showed that we can click on an equation and move the cursor around, and once it turns into a hand symbol, we can just move it around. 600, click outside, you get 600. Now one thing that is very important, that although this is a scratch pad and you can type things in unformatted wherever you want to, there's a precedence you have to follow. MathCAD evaluate things on a top to bottom, left to right precedence sequence. So the only reason why MathCAD is able to tell you that x is equal to 6,000 is because there is a function that evaluates that, or there's an equation that evaluates that value, or there's an assignment prior to that. And prior means up or left. Okay, so for example, I can actually move this to the right and it will still tell me that it's 6,000. I can actually move it all the way to the right and it will tell me that it's 6,000. I can move this to the right of these and it will tell me that it's 6,000. But as soon as I'm going to bring this back to the left, as soon as I move this value below or to the right of these, notice that it doesn't know how much x is. I am asking to display x before I define it. So MathCAD evaluates things from top to bottom, from left to right. That is the sequence of precedence that MathCAD uses. If I try to define x to the right of where I try to display it, obviously the display is giving me an error, it's making the x red. And if I click on it, it's going to give me a message. This variable is undefined. Okay? There's not much to that. You just got to keep in mind And always remember that the precedence sequence is from left to right, top to bottom. Okay? Let's go to the presentation. Editing and deleting equation. You can edit an equation by first clicking on it. Move the blue input cursor. Once you're editing an equation or typing in, the cursor, the plus sign, the red plus sign turns into a blue cursor, and that blue cursor tells you exactly where you are, where you're located within the equation. So let's try to change that equation, the first one we wrote, 50 times 120, to something else, and let's see what happens. An equation can be deleted by repeatedly pressing the backspace within the equation, or just by simply selecting the entire equation and clicking delete instead of the backspace. You can also click and drag a selection box over several equations, hit delete, and it will delete all of the equations. Okay. You can also use the spacebar to edit within the equations, because the spacebar and the cursor keys within your keyboard will actually move that blue cursor within the equation to several locations, several key locations, until you find wherever it is that you want to turn in or transform or change a value. So let's go to the MathCAD spreadsheet right here. I'm going to move this more towards the middle of the screen. And let's say now, well, I made a mistake with this equation. I'm going to change it. Okay, that wasn't actually 50, it's actually 60. So notice that if I click right where I want to, it will place the blue cursor exactly where I want to edit. If I click somewhere else, it will place it somewhere else. I can change the location of that blue cursor by using the keys, the cursor keys, and the keyboard. Or I can use the spacebar to select the entire equation to the right, or to select the entire equation to the left. So the spacebar moves you to key locations within the equation, and the cursor keys move you to the right or to the left. Okay, so I'm gonna locate this the cursor right after the 5, hit backspace, and type a 6, and now I have 60. As soon as I click outside or hit enter, notice what happens. The values change. So MathCAD actually performs parametric analysis automatically. Anything you change within the MathCAD spreadsheet will be changed automatically, and that's because automatic recalculation is set by default in MathCAD. So those are some things, some features that we're going to be changing, and we're going to be looking at in future sessions. Okay, how to actually turn off the automatic recalculation to save some time. Let's say that we're typing 100 equations and we don't want this recalculation to happen every time we change something, but we're just interested in the final solution. We type everything, then we turn recalculation on, and then we get the solution. But if you change anything, I'm going to change this to 100. Notice what happens. Back to 6,000, back to 600. Everything that depends on X will change automatically as I change any value on the definition. So the value of X itself and the value of Y, which, by the way, also depends on X. All right. So let's go to the presentation again. We can also use indices or subscripts for text visualization or for indices. Okay, there's two different types of subscripts in MathCAD, and we're going to be using the second one heavily when we introduce vectors and matrices, which is in a future session. But today we're just going to talk about the difference between the two. The text subscript is used for visualization purposes only. Maybe you want to define a variable called xi and another variable called xf, like an initial value of x and a final value of x, and you want to do that, and you want to make sure they're independent from each other, but maybe you want to show the I and the f as a subscript of x, just for visualization. Okay, the I and the f is not a counter, it's not an array index within the variable, it's just a subscript. And you can do so, you can insert subscripts by using the period. Okay. The other type of subscript is the index, it's the actual index, which actually defines a position within an array, and that is used, that's inserted with the left square bracket sign. Okay, and we're going to be using this a lot. The second one, this index subscript, we're going to be using this a lot when we introduce a concept of vectors and matrices in MathCAD. We're going to do so, obviously, in a future session, and we're going to be using this heavily. So let's see. Back to MathCAD. So let's say I want to define a value of x dot I. Okay, notice that the dot still shows, but it is showing as a subscript already, and I want to define this as 3, or let's say 30, and x dot f, and I want to define it as 120. Okay, now this xi and this xf, notice that the only difference between them is a subscript. That subscript is just a text subscript. There's no relation between this variable and this variable. They're completely independent from each other. They're just named similarly, but they have a different text subscript. So this variable and this variable are completely independent from each other, and they're completely independent from the variable x up here. Alright? So I can define a third variable, x.m, for example, medium or mid value, as x.I plus x.f. And with the spacebar, I see the spacebar or the cursor, I'm going to select both xi and xf divided by 2. Notice that when I click outside the equation, the dots disappear. The dot I disappears, and the only thing that remains is I. It's just the definition of the variable. So x.m is equal to 75. So I've defined a third variable that depends on the other two that have just text subscripts. That's like, again, this text subscripts are just for the purpose of defining a variable that has a slightly different name than another one. It's just a change of semantics, change the names. There's no relationship between this variable and this variable. They have nothing to do with each other. The I and the f is just another name if I wanted to give the, just like if I wanted to give the variable a name y or z, it's just I wanted to name it xi and xf. The other type of index is the subscript index. Is entered or inputted with the left bracket, left square bracket, and that's actually defining a position within an array. So I can say, for example, t, the variable t, but now the variable t has a position, left bracket, 0, and that value I'm going to define it as 22. t1, I'm going to define it as 31. t left bracket 2, I'm going to define it as 9. And t left bracket 3, I'm going to define it as, I don't know, 12. So I can come right here to the left, to the right. Once everything is defined, I can say, give me the value of t, and notice it gave me a vector or an array. Remember, vectors is a one-dimensional matrix. It's a column vector, and it gave me all the values from value 0 all the way to value 3, 0, 1, 2, and 3 of the ones that I define up here. So in the case that you use index subscripts, the ones that are entered with the left square bracket, there is indeed a relationship between this variable and this variable and this variable. They're not independent from each other. They are positions within an array, and the array is just called t. In this case, this is not an array up here. This is not an array called x with position I and position f. This is just a variable called xi, and this is a variable called xf. Alright? So that's the difference between the two. Let's go to the presentation. Units. Another very powerful feature of MathCAD is its ability to work with units. By default, MathCAD works in the SI unit system. Remember, meters for length and kilograms for mass, and seconds for time. That's the same as a British unit system, and so on. So MathCAD understands and processes a variety of units in different systems. There are two different methods of inserting units. So if when you define a variable, let's just define a variable called L, for example, for length, and let's specify that length, we're going to provide that length to MathCAD in inches. Okay, we can insert the inches by just simply typing in, or if we don't know the actual acronym for the variable, for the unit, we can go to the insert unit command from the menu, from the pull down menu. Okay, and then let's display the value of L, or the value of length, whichever way we want to call that variable, and see what happens. Now MathCAD handles many unit systems. The SI as the default, the international system where mass is in kilograms, length is in meters, time is in seconds, current is in amps, charge is in coulombs, temperature is in Kelvin, and luminosity and substance. It can handle all of these. And then the MKS, which is very similar to the SI unit system. It's the meters, kilograms, and seconds. The CGS is centimeters, grams, and seconds. The US unit system, the feet and the inches and the pounds and so on. And a user-defined system, which you can define yourself, obviously. So let's go to the presentation. Let's go to MathCAD. And let's say that we are going to define a variable L. By the way, MathCAD is a case-sensitive software, so capital L is different from lowercase l. You can define two variables that are independent from each other, one called capital L and the other one called lowercase l. So capital L is, let's say, 100. But we don't want to just say 100, we want to say 100 IN. Notice that when I typed IN, MathCAD automatically understood that IN is inches and separated the two values with a dot, meaning that is 100 times inches. That's the way you define a value in a unit system. Okay, it's actually the quantity times the unit that you want to refer to. So it's 100 inches. So when I want to define, by the way, that green rod underneath the L is just a warning. Okay, don't worry about that. That means that there's a possibility that there's a conflict, meaning that more than likely you are defining a variable that is already defined somewhere. And since in our path we haven't defined any L, any capital L, it probably means that that L is a variable that MathCAD has a default value for. Okay, there's certain variables and certain names that MathCAD reserves for other purposes. And maybe L is defined for something else. Okay, inductance or whatever. Anyways, let's just call it LE, for example, and there's no conflict. Length, LE, or LEN, let's say LEN. And there shouldn't be any conflict. And actually there shouldn't be any conflict if we use L, we just got that warning. Alright, so LEN, 100 inches. What happens when I try to display LEN? LEN equal, I get 2.54, well that's not the value that I enter. But by default, since MathCAD uses the SI unit system, has given me the answer and is displaying the value of length that is in memory in the unit system of MathCAD, which is set at this moment to the default system, 2.54 meters. Okay? So what if I don't want the length in meters? I can just say, I can just come in here, select the equation, notice that there's a placeholder to the right, and in that particular placeholder I can type the unit in which I want the value in. If I type IN, I'm going to get 100, which is exactly what I enter. I'm going to go to the placeholder again, click on the equation, I'm going to delete inches, and on this right placeholder I'm going to say FT for feet, 8.333 feet. Okay. Now notice that MathCAD only gives you 3 decimal places. That doesn't mean that MathCAD truncates things in memory. Actually, the value that is in memory is 100 inches, which is 2.5402, so on and so forth, meters. But that value is saved and stored in the MathCAD memory with all the decimal places in actual precision of the machine, and the IEEE precision of this machine, which is by default set to single precision, which can handle 8 decimal places. However, it only displays 3 because it's just display precision. It's just for show. It's just what it's telling you the value is. Okay, so I can change the unit by just deleting FT, and let's go back to inches. And if I don't specify any units, and I just say display, it's going to give it to me in the default unit system, which is the SI, and obviously length are given in meters. Alright, we also said that we can enter units. Let's say that if we don't enter any units, the length is just 100. It's a unit less quantity. But in the definition, we can insert unit, and in the system SI, which is by default, notice it's grayed out. And I'm going to go to a unit of length. Oops, it's up here. And I am going to enter this in IN, inches. So if you, for example, didn't know the acronym for inch, which is lowercase in. This is telling you what would it be in parentheses, or I can just say insert it from here, and there it is. Okay, many ways of inserting units, and it's very practical because it does a conversion for you on the fly. So if you enter input values to a specific problem that you're working on, and those input values are in all kinds of different units, and you have meters and inches, and then you have forces in newtons, and some other forces in pounds, and then you have some distance in kilometers, and some times in seconds, and another ones in minutes, and then you try to use those inputs to find a solution for your problem, it would automatically convert everything to SI, which is a congruent and consistent unit system, and give you a solution for it once you operate these values. Alright, as I said, MathCAD has a set of predefined values that are within constants or just variable letters, and some examples are the value of pi, the value of e, the Neperian number, and g is the acceleration of gravity, which is 9.8 in the SI unit system. So let's see. Say for example that I wanted to define a variable called g, and I wanted to give it the value 10. It's going to give me a warning. See the green? It's because g is not reserved by MathCAD. You can use it, but it's predefined by MathCAD. That's telling you that you're overriding that value. Okay, so I'm going to forget about that. I'm going to say how much is g? It's not defined anywhere. How much is g? 9.807 meters per over second squared. That's the default acceleration of gravity on the surface of the Earth in SI unit systems. Okay, how much is e? The Neperian number for the natural log, 2.718182, so on and so forth. You only see 3 decimal places, but in the MathCAD memory is registered with all decimal places, not all of them, but to the precision of the machine. And then pi. How do I enter pi? There's many ways of entering a Greek letter. One way is just, well, if you know the translation into our Latin alphabet, then P corresponds to pi in the Greek alphabet. So you enter P, Control G to transform to Greek, and let's say for example if you had another Greek letter, W, Control G transform into omega, and for example H, Control G transforms into eta, and A obviously transforms into alpha. So you just press P, and then right next to it Control G, and it will turn into a pi. Display 3.142. Well, so obviously the round off displayed value of pi is not 3.142, it's 3.1415, and so on and so forth, 92, etc., etc. But that's the value that's in memory. The value that is displayed for space purposes is just the 3 decimal place truncated value, or not truncated, round off value. The other way of entering Greek letters is to the Greek toolbar. I'm going to go to the MathCAD toolbar right here, click on the Greek symbol toolbar, pi equal 3.142. Okay, I'm used to typing it with a keyboard. If you know the translation between a Greek letter and a Latin letter, you just simply click Control G. Okay, the Latin alphabet and the Greek alphabet are derivatives of each other. The second is derivative of the first, and then you can pretty much find a correspondence between every letter in one alphabet to every letter in the other. Alright, so those are predefined constants in MathCAD. Let's continue with the presentation, and let's see. Entering text. You can enter text in MathCAD in 3 different ways. By, well, text is just if you want a title to what you're doing, if you just want a caption, is something that is not, that's just a comment that is not going to be evaluated by the MathCAD engine. It's just going to be there for you to see what it is. Okay, if say that you're trying to make a report out of these scratchpad, and then you try to organize it nicely and neatly, then you just type text wherever you want to. You can do so by using the quotation mark, the double quotation mark. You can go to Insert Text Region from the pull-down menu, or you can do so by pressing the spacebar after typing anything on the pad. So let's say I'm going to add a title to these. I'm going to move it down here, and the title is going to go here. And I'm going to say these are constants, are MathCAD constants. So I'm going to say this. Notice that since you're typing THIS, MathCAD still thinks that you're typing in the variable name, so it gives you the blue cursor. But as soon as you hit the space bar, it turns it into text, into formatted text. This is, or these are some MathCAD constants. Okay, and I'm going to select. We can bold it, you can underline it, you can italize it, and just for visualization purposes. So you can also do that. Let's delete this by using the double quotation mark. It automatically opens a text region. These are some, so on. You hit enter and you get a second line, or you can do so up here by inserting text region, and then you can type whatever you want. So I'm gonna undo, Control C, Control C, Control C, Control C until I get the first one that I typed. I can undo, undo, undo many times until I get where the point where I want it to go. So notice that we're reaching the end of the scratch pad. There's not the end of the scratch pad. We can type as many things as we want down there or below this line. It's just giving you a virtual break between pages. So if you needed to print this, this is where page number 1 will end. We can force a page break by hitting Control Enter and keep typing now on the next page, at the beginning of the next page. Same way you would do it in a regular word processor. Now let's talk about range variables. Range variables is a way of defining a variable that has multiple values. It is similar to an array, but it's not an array, and I'm going to talk about the difference between a range variable and an array in a second. So pretty much it's just a variable that contains several values within it. Let's say that we want to define I, a variable that goes from 0 to 10 in intervals of 1. The way to define it is with a semicolon. I define I as column equal, definition equal, or assignment equal, 0, semicolon, 10. And when I display the value of I, I'm going to get all 11 values from 0 to 10. So say I wanted to define another variable that is not necessarily in increments of 1. It goes from 0 to 10 but in increments of 0.25. I define the second value as 0, 0.25, semicolon 10, and then when I display J, I get all those quantities between 0 and 10 in intervals of 0.25. Those are 41 quantities. Okay? So let's go to the, and this is what you're going to see when you enter this in MathCAD. Enter I from 0 to 10, J from 0 to 10 in intervals of 0.25. This is not the interval, this is the second value right after 0. So let's go to MathCAD and let's enter a text region, range variables, and let's just bold and underline this just for reporting purposes. And I'm going to say I is defined as 0, semicolon, 10. Notice that when I hit semicolon, 2 consecutive periods are displayed. Okay, doing that is not the same as saying I is equal to 0, period, 10. That is not the same. Okay, it will give me an error. Notice that I turned the equation in red. Cannot understand the syntax. Okay, it's a semicolon. So when I display the value of I is equal to, it gives me all the values between 0 and 10 in intervals of 1. And the interval of 1 is because it's the default value. Okay, I could have said the same thing as 0, 1, semicolon, 10, and it will give me exactly the same thing. Alright, so let's define J, 0. I can start it wherever I want to. I don't have to start it at 0, but let's say 0, 0.25 to 10. And let's display J. I should get 41 values between 0 and 10 in intervals of 0.25, but I don't see all of them. Only the first 17 are displayed. But if I click on any of them, I can move a scroll bar all the way to the bottom. So that is a range variable. Okay? I can start it wherever I want to. I can start at 1, but then I'm going to have to say that the next value is 1.25, and there it is. Now it's a range variable that contains 31 values between 1 and 10. Actually no, 37 values between 1 and 10 in intervals of 0.25. Okay? So 0, 0.25, and 10. The difference between a range variable and an array is going to be obvious when we talk about arrays, but for now you can just say that an index variable or a range variable is a variable that contains several values, but you cannot access every one of these values independently. Okay, you cannot access a value within the range variable. You can use all these range variables for a specific purpose, to index an array, for example, but you cannot access specific values within the array. In an array, within the range, in an array you can actually access independent values within the array, whether it is a two-dimensional array like a matrix or a one-dimensional array like a vector. You can access these values. In a range, all you have is a definition, okay, that will serve a purpose later. Functions. Okay, so we're coming into the second part of this lesson today, in which we're going to talk about different functions in MathCAD. First of all, let's talk about the fact that you can define your own functions in MathCAD, which is the main ability of MathCAD. You can define a function that can mean anything, or you can just define a mathematical function for the sake of defining a mathematical function. Let's say that we define a function that depends on x and y, and that function is x plus y squared. It's a D function, which can be anything. You can define a function called z, or your name, or whatever it is, and it just depends on x and y because we are explicitly saying so with the use of parentheses. We're defining the function with the assignment equal, and that is equal to x plus y squared. And then we can evaluate that function later. We can plot it, graph it in 3D, whatever we want to do. But notice that what we're trying to explore at this moment is MathCAD ability to handling functions. So I'm going to say functions, space bars, make sure we're telling this MathCAD this is just the title, text region, and I'm going to define a function D of x and y. Okay, I'm explicitly saying that it's a function of x and y as x plus y squared. By the way, a function doesn't have to be a function of x and y and z. It can be a function of anything, of L and T, whatever. You're explicitly saying so. If you define a function P, for example, of T and R and H, and then you say this is T times maybe the thickness, the radius, and the height, thickness times R squared times pi times H, for example, and then you say enter, that's fine. But let's say that you forgot to say in the dependency that this was a function of H, you're going to get an error. See, the H is written in red because I gave you an error that you forgot to say that this variable has not been defined anywhere and it's not a dependency of this function. So this function D is a function of x and y, and the definition of the function is x plus y squared. You can define it whichever way you want to. And then you can evaluate. Give me the value of D when x is equal to 1 in that order. X is equal to 1 and y is equal to 2, and you will get 5. Give me the value of D when x is equal to 3.1 and y is equal to 1.3, 4.79. Automatically, you define a function and you can automatically query a value of the function at a specific location. You can also use built-in functions in MathCAD. MathCAD has a wide variety of built-in functions. We'll probably have no time. I've used MathCAD for over 15 years, and there's still times where I use MathCAD and I find out that it has another function that I didn't know about. And obviously new versions of MathCAD have more functions. Got all kinds of mathematical functions, from the very basic trigonometric functions, sine, cosine, tangent, and so on, logarithmic, exponential, and then to the very sophisticated mathematical functions, Bessel functions, and then elliptic integrals and error functions, and so on. You have all kinds of functions in MathCAD already predefined for you that you don't have to really worry about anything when it comes to using a mathematical definition, because more than likely it's already in MathCAD. So let's say we can use sines, cosines, and so on. Let's just test that. And notice that when we test a sine function, for example, and we say, well, give me the sine of 30, we don't get 0.5. In this case, we're defining a function as 3 times the sine of x, which should give me 1.5. That is because by default trigonometric functions and inverse trigonometric functions in MathCAD are in radians like they should be. Okay, so we have to specify the angle in radians, or if you use an inverse trigonometric function, the angle will be given to us in radians. Remember that 180 degrees is 1 pi radians. So if we want to specify 30 degrees, we have to specify 1/6 of pi. Okay, 0 degrees is 0 radians. 180 degrees is 1 pi radians, or 3.1415, so on and so forth radians. So 30 degrees is 1/6 of a pi. Okay, so if I actually say, give me the sine of 30, I'm not going to get 0.5. I know that the sine of 30 degrees is 0.5, but the sine of 30 radians is definitely not 0.5. So if I say, give me the sine of pi over 6, which is 30 degrees, that's a 6 of pi radians, I get 0.5. I can define a function, if I wanted to, y of x is equal to 134 times the sine of x plus 1. It doesn't matter. It just uses a trigonometric function within it. It's giving me a warning because I already used y all the way up here. I use y for something else. So I am redefining, and that's fine. I can query the value of y at pi 6 now. Now let's say the value of y at 1 radian is 121.846. Okay, and the same, I can use y of x of the cosine of x. Same thing. Give me the y of pi over 3. 60 degrees, it should be 0.5. Of 30 degrees, it should be square root of 3 over 2. The cosine of 30 is the square root of 3 over 2, which should be 0.866. Let's see. Square root of 3 divided by 2 is 0.866. Oh, it works. Great. Going back to the presentation, I also have exponential logarithmic functions, natural logs, and log base 10. So let's say I can say, well, give me the exponential, or I can define a function y of x as the exponential of x, and I can tell, give me y of 3. How much is the exponential of 3? 20.0.86, which should be the same as saying e to the power of 3. Let's see, exactly the same. We can define a function as the log, natural log of x. Now give me the natural log of 3, and I get 1.099. Actually, give me the natural log of e, that should be 1, right? And give me the natural log of 1, that should be 0. And we get it. I can define a function y of x as the log base 10 of x. Give me the log base 10 of 10. I should get 1. Of 100, I should get 2. Of 200, 2.301, so on and so forth. So I'm going really fast over these because this is just predefined functions within MathCAD that we'll have a chance to test, and many different applications that we're going to be going over these on these tutorials. Exponential, logarithmic, logs, all the ranges of trigonometric functions, sine, cosine, tangent, secant, cosecant, and cotangent, which, although they exist, they were not necessary because, as we know, the cotangent is the inverse of the tangent, the secant is the inverse of the cosine, and the cosecant is the inverse of the sine. Inverse trigonometric functions, the arc sine, the arc cosine, and the arc tangent. Remember, you provide the value, you get the angle, but the angle you don't get in degrees. You get the angle in radians. So if you say, give me the arc sine of 0.5, you're not going to get 30, you're going to get pi over 6. Let's see. Give me the arc sine of 0.5. I don't get 30, I get 0.524. How much is that? That should be identical to pi over 6. So you get the angle in radians, 0.524. Well, it works. Then we have hyperbolic functions, which functions that at this point you might not be familiar with, but later on in your calculus classes or in your engineering classes you're going to be using heavily. Sine hyperbolic, cosine hyperbolic, and so on. Those are functions that are defined through exponentials, but they have certain characteristics that are similar to trigonometric functions, like the derivative of hyperbolic functions are recursive, such as the trigonometric. The derivative of the sine is a cosine, the derivative of the cosine is minus a sine, almost the same for the hyperbolic functions, but they are defined through exponentials. Inverse hyperbolic functions, same thing, a sine h, cosh, tanh, so on and so forth. Then we have this interesting functions: the floor, the seal, and the mod. Let's see what they are good for. The floor of 1.73 is 1. It will just completely truncate a value. So if we say 1.3, it will give us 1. Even 1.99, it will give us 1. It will just truncate the value. It will give us the integer. The seal will round off. Round up the value. So if I say 1.73, I'll get 2. Even if I say 1.12, I'll get 2. And mod is the residual of an integer division. Okay, so let's say, what is the residue of 10 divided by 2? Well, 10 divided by 2 is 5, but the residue is 0, so I get 0. But if I say 11 divided by 2, that has a residue of 1. 11 divided by 3 has a residue of 2. So I get the residue of an integer division. That's what mod is for. And it's useful when we have to do things as checking every few times in a step, or every few steps in a sequence, or actually conversions of between numbers and different bases and so on. And finally, we got a couple of functions that we may or may not encounter in some of our analysis, but down the road in your engineering studies you're going to get to use some of these. First of all, a conditional value, if, then you input a condition, and then you specify what would be the true value and what would be the false value. False response and the true response. We'll get to that. The Kronecker delta, we'll explain that. The Heaviside step function, and the random number generator. These are some examples, but there are literally thousands of different functions within MathCAD. So I'm going to go back here and I'm going to say, well, the first one is the if. I'm going to say x is equal to 0.5. 0.5. Okay. And then I'm going to ask a question. Set y to, I'm not going to say anything, I'm just going to say if x is less than 1, then set y to 10, and if not, then set it to 20. So what is the value of y now? It's 10 because x is less than 1. But if I make x all of a sudden 1.5, then y takes the value of 20. Okay, so it's just a conditional function with a true and a false value. So I'll assign the true value to y if the condition is true, and I'll assign the false value to y if the condition is false. The Kronecker delta is D, Control G is delta in Greek, a no-brainer, is D Greek. It requires two indices, I and j, so let's say 10 and 20. The value of that is 0. The Kronecker delta is a function, it's a discrete function that will give me 1 whenever the two indices are equal to each other, and 0 whenever they're different from each other. So it's basically kind of an identity matrix. Only the diagonal has 1s, everything else has 0s. So if I say give me the Kronecker delta of 3,3, I'll get 1. But at position 3,2, I get 0. So whenever the indices are different from each other, I get 0. Whenever they are equal to each other, I get 1. The Heaviside step function, capital F, G, that's phi, capital F, Control G, is a phi Greek letter, capital F. It will give me the Heaviside of 0.5 is 1, but the Heaviside of minus 0.5 is 0. So whenever the argument is less than 0, I get a 0. Whenever the argument is greater than 0, I get a 1. Okay, so if I type in a 1.4, I get a 1. But if I type in a minus 0.2, I get a 0. Okay, so it's another discrete function. It's a step, which you're going to be using heavily also in some calculus classes, future calculus classes, and some electricity classes, and some more. And then the last one that we talked about is the random number generator, which will generate a random number, uniformly distributed random number, almost completely random. It uses a pseudo-random sequence inside to calculate it, but it's you can pretty much trust that it's going to be a random number between 0 and the number you specify in parentheses. So I want a number between 0 and 1. Give me a random number. Well, 0.00. Let's say between 0 and 10. 1.933. Okay? If I do this again, it will give me a completely different value. If I delete this and do it again, a completely different value. It's always generating a random number, uniformly distributed, because there is no specific arrangement pattern. It's just random numbers scattered between 0 and 10. 7.10, 3.04, and I can. So again, as I said, you have always the menu help. You can just go to help and click MathCAD help for general help, or you can just step over a function that you don't understand or you want to know about. So you put the cursor over R&D, click F1, and then you're going to get the help. There it is. Uniform distribution. There's a couple of different functions for uniform distribution: dunif, punif, qunif, R&D, which returns a uniformly distributed random number between 0 and the value you specified, x, and also one that generates a vector of m random numbers between a and b. So actually not between a and b, having a uniform distribution a and b. Alright, so these are some examples of how to use functions within MathCAD, and some examples of some built-in functions. But as I said, there are literally thousands of functions within MathCAD. Obviously, it will be virtually impossible to go over all of them, but here's a sample. And if you're solving a specific problem and then you run into a specific function that you don't understand, and then you're wondering that function is in MathCAD, say that you run over an error function. What is an error function? Well, an error function is defined through an integral, and it's a complicated function, but chances are the MathCAD already has it. So you just use it. You can say error function of 2, and you get a value. Okay, and that is the definition of the error function, which is a very complicated definition, but MathCAD already has it in it. Okay, so this is it. And this is the last page of the presentation today, and in future lessons we'll go over more advanced features. We'll continue with graphing and so on. Thank you very much, and I'll see you next time.